Symmetry of a graph. We have discussed about points, line segments, lines, circles, and parabola. Now how can each of them be symmetric? Points A and B are symmetric with respect to x-axis if and only if the axis is perpendicular bisector of line segment AB, or there's a 90-degree angle between them. It also means that if a point A with coordinates xy is on a graph symmetric with respect to the x-axis, then the point B with coordinates x negative y must be on the graph also. So the coordinates xy and x minus y must satisfy an equation of the graph. Likewise, points P and Q are symmetric with respect to y-axis if and only if the axis is perpendicular bisector of line segment PQ. This means that since point P with coordinates negative x, y is on a graph symmetric with respect to the y-axis, then the point Q with coordinates xy is also on the graph. Points A and B are symmetric with respect to a third point if and only if the third point is the midpoint of AB. This circle is symmetric with respect to the x-axis, y-axis, and the origin. And this parabola is symmetric with respect to the x-axis. This is the first theorem in testing for symmetry. For example, in this equation y squared equals x minus 2, y can be positive or negative, but x is the same. So the parabola is symmetric with respect to the x-axis. This is the second theorem. In this equation, y equals negative x squared plus 1, x can be positive or negative, but y is the same. So the parabola is symmetric with respect to the y-axis with this equation. And the last theorem for testing symmetry. As the theorem suggests, when both x and y are replaced by their negative counterpart, then the graph is symmetric to the origin. To summarize, we discussed about how to show that the graph of an equation is symmetric by the following theorems.